Okay, so let's do an example of a word problem that pertains to exponential functions. So it says, suppose 30 flower beetles are left undisturbed in a warehouse bin, and it says the beetle population doubles each week. And question A is asking you to write an exponential function that models this situation. Okay, so if you leave some beetles in a box for a while, what's going to happen is they're going to start mating, and the population or the number of beetles in the box is going to go way, way up really, really quickly. Okay, so what our job here is we want to write an exponential function that models this scenario. Okay, when it says exponential function, what that should mean to you is you're going to write an equation that follows this format. Y is equal to A times B raised to the x power. Okay, and when we write this equation, we got to figure out what this number is for A and what this number is for B. Okay, if we have those two things, we'll have the exponential function. Okay, so here's what you need to know about exponential functions and when they allude to population growth. Okay, we got to know what both of these variables stand for, x and y. Okay, when you're dealing with exponential growth, x is going to represent the amount of time passed. We'll say x is equal to time passed. Okay. Whether it's 1 week or 3 weeks or 5 weeks, we want to be able to plug in a number in for x and then be able to solve for y. Y should be able to tell you, in this case, it would be the number of beetles. Okay, we want y to tell us how many beetles are remaining in the bin after X amount of time has passed. Okay, and if we have the numbers for A and B, we're able to solve for it for any number of weeks. Okay, so this might be a little bit complicated, but let's see if we can reason our way through it. How can we solve for two different numbers? Okay, here's the first step. If we want to solve this equation, the first step is we need to be able to solve for the letter A. We got to figure out what number goes right here. And here's how you do it. You're going to solve for A by plugging in erase that, by plugging in zero for x. Okay, solve for this letter A by plugging in 0 for x. Okay, so if we read the scenario again, it says, suppose 30 flower beetles start in the bin. Okay, our initial time after 0 time has passed, we know that there are 30 flower beetles in the bin. Okay, just off of this one statement, we have enough information to write an equation. Okay, so remember, y represents the number of beetles in the bin at a given time, and then x represents the amount of time that has passed. So at the very start of this thing, I'm going to have 30 flower beetles in my bin. Okay, y is equal to 30. Okay, I still don't know what A is. I still don't know what B is. But what I do know is that at the start, after 0 time has passed, when x is equal to 0, my y value is equal to 30. Okay, my initial population is equal to 30. Okay, so this looks a little bit weird, but what we actually have is we have enough information to be able to solve for A at this point, using one of our exponent properties. And what do I mean by that? Well, what do we know? Anytime we have something raised to the 0 power, what is it equal to? B to the 0 power is equal to just plain old 1. So if I were to clean this up a little bit, I would have A times 1 is equal to 30. And what's anything times 1? It's just itself. A is going to be equal to 30. In my equation, 30 is going to be equal to A every single time. Okay? Now, what we're going to do is, because we have enough information for A, we can plug this value into the equation to solve for B. Okay. So, step 2 is this. You're going to solve for B. Sorry, it's a little bit sloppy towards the bottom. By plugging in a value for X. Okay, so what do I mean by that? Let's read that first statement again and see what we know. Suppose 30 flower beetles are left undisturbed in a warehouse bin. And it says the beetle population doubles every week. Okay, so we know after 1 week, we should have double the amount of beetles we started with. Okay, so if we started with 30 beetles, after 1 week, we should have double the starting amount. Double of 30 should be equal to 60. Okay? Now, what are we going to do next? What we have to do next is we got to figure out what B is equal to. We already know what A is equal to when we solved it for it first. A is still equal to 30. I don't know what B is, so I leave it as a variable. But I know after 1 week, I should have 60 beetles. After 1 week has passed, I should have 60 beetles. So X in this example would be equal to 1. Okay, after 1 week, our population doubles. We go from 30 to 60. Okay, so what we have right now is enough information to be able to solve for B. 30 times B to the first power. Okay, B to the first power is just plain old B. So what I know is I know 30B is equal to 60. And I want to solve for B. I want to solve for that variable. So I divide both sides by 30. And I should get B is equal to 2. Okay, so I did some work. And now I know what these two letters are equal to. A is equal to 30. B is equal to 2. I can rewrite my final equation in that format, but using my variables in the equation. So the equation that models the situation is this. Y is equal to 30 times 2 raised to the x power. And this equation will help me solve for the number of beetles after any given number of weeks. Y is equal to 30 times 2 to the raised to the x power. Okay, so question B is asking how many beetles will there be after 56 days? Okay, we have enough information after we have this equation to solve for this. Okay, but the one thing that's important to remember is we wrote this equation with respect to weeks. But they're telling us, they're asking how many beetles will be in the bin after 56 days. Okay, so the first thing we gotta do is we gotta convert this to a number of weeks. Okay, there are 7 days in a week. 56 divided by 7 is equal to 8. 56 is the same thing. 56 days is the same thing as 8 weeks. So if we're trying to solve for the number of beetles after 8 weeks, all we have to do is plug this time in for x. So what I'll have here is I'll have y is equal to, solving for the number of beetles, 30 times 2 raised to the 8th power. Okay, once you have that, it's a pretty simple plug and chug. We just got to make sure we count for order of operations. You have to do 2 to the 8th power first. You have to do your exponents first. So if you do 2 to the 8th power, you'll get a pretty large number. You'll get something like 256, and then you multiply that number by 30. 30 times 256, and you should get this number of 7,680. It goes up really, really quickly. But we know after 8 weeks, we should have 7,680 beetles in our bin.